At the dawn of the 20th century, when humanity finally conquered the skies, there was a silent problem that threatened the entire American aviation industry. While engines roared and propellers cut through the air, there was a tiny component, no bigger than a man's fist, that determined whether a pilot would return home safely. This is the story of how a French immigrant named Albert Champion forever changed the rules of aviation, not with bigger wings or more powerful engines, but with a spark of genius that transformed bits of metal and ceramic into the guardians of life in the air. When the Wright brothers made their first flight at Kitty Hawk in December 1903, they not only achieved the impossible, they opened a door that could never be closed again. But what many don't realize is that first flight, those historic 12 seconds, depended on something far smaller than canvas wings or the courage of the men. It depended on an electrical spark happening at the exact moment, at the right temperature, under extreme pressure. And in the years that followed, as aviation evolved from a curiosity to a military and commercial necessity, that small component would become the Achilles heel of the American industry. Albert Champion was born in Paris in April 1878, at a time when the Eiffel Tower was still under construction and the idea of flying machines belonged to dreamers and visionaries. But Champion was not just a dreamer. He was a mechanic, a man whose hands understood metal and whose eyes saw problems where others saw only machines working. He grew up in a world being transformed by the Industrial Revolution, where speed was becoming an obsession and where each new invention promised to liberate humanity from the limitations that had defined all human existence until then. As a young man, Champion found his passion in bicycles and soon after in motorcycles. He wasn't just an enthusiast, he was a competitor, a man who understood that speed wasn't just about raw power, but about efficiency, about making every component work in perfect harmony. And it was in this pursuit of perfect speed that he found his true calling. Because in every race, in every engine he disassembled and rebuilt, there was that one small component that failed, that burned out, that left riders stranded on the track when they should have been crossing the finish line. The spark plug. A simple name for a complex problem. If you're enjoying this story, don't forget to subscribe to the channel and leave a comment letting us know what time you're watching. Your participation helps this content reach more people interested in fascinating stories from engineering and aviation. In 1908, Champion made a decision that would change not only his life, but the future of aviation. He left France and crossed the Atlantic to America, that land of limitless opportunities where men with bold ideas could build empires. He didn't come with fortunes or connections. He came with knowledge and a deep understanding of a problem that most people didn't even know existed. America was in love with the automobile, and Champion saw an opportunity. He started working with spark plugs for cars, but his eyes were already set on the sky. Because while Champion was establishing its reputation in the automotive world, something extraordinary was happening above. Aviation was ceasing to be a showpiece and becoming a serious technology. And with World War I looming on the horizon, the need for reliable aircraft was no longer a matter of national pride. It was a matter of survival. The Europeans, especially the French and the Germans, were developing fighter planes that could fly higher, faster, and longer than anything the Americans had. And at the heart of this technical superiority was a component that the Americans simply couldn't manufacture correctly. The spark plug seems simple. It's just an electrode surrounded by ceramic, inserted into a metal cylinder, designed to create a spark that ignites the air-fuel mixture inside the engine. But that simplicity is deceptive, because that spark needs to happen thousands of times per minute, at temperatures that could melt ordinary metal, under pressures that would shatter glass, and in an environment drenched in oil and combustion residue. And in aircraft engines, where reliability is absolutely critical to flight safety, the quality of this component was non-negotiable. The aircraft engines of that era were ferocious and temperamental beasts. They required extreme heat to function efficiently, far more heat than ordinary automotive engines. And that heat was the problem. American spark plugs, made with materials and techniques suited for cars and motorcycles, simply couldn't withstand the brutal conditions inside an aircraft engine operating at full capacity. The ceramic cracked, the electrodes melted, the ignition failed. And when the ignition failed during critical missions, the consequences were severe, putting lives at risk. Champion watched this disaster unfold with the frustration of a man who knows the solution but lacks the means to implement it. He understood the problem intimately. It wasn't simply a matter of making the sail stronger or using more durable metal. The challenge was to create a component that could reliably conduct electricity, efficiently dissipate heat, withstand extreme thermal shock, and yet be light enough not to add unnecessary weight to an aircraft where every gram mattered. It was an engineering problem that demanded not only technical knowledge but also a deep understanding of materials science, thermodynamics, and precision manufacturing. When America entered World War I in 1917, the problem became a national crisis. The country that had given the world the airplane now found itself desperately behind in the aeronautical race. American pilots were flying French and British planes, equipped with European engines, because American engines simply weren't reliable enough for combat. It was a national humiliation and a strategic danger. The American government desperately needed to develop a domestic aircraft industry, but repeatedly ran into that same seemingly insignificant problem. Spark plugs failed. Champion saw his opportunity and his duty. He had spent years perfecting spark plugs for automobiles, building a reputation as the best in the business. But he knew that what worked in a car wouldn't work in an airplane. He needed to start from scratch, rethink every aspect of the design, every material, every manufacturing process. And he needed to do it fast, because the urgency of the situation was extreme and lives depended on the solution. The first challenge was heat. Aircraft engines of the time, especially rotary engines and the powerful inline engines that were being developed, operated at temperatures far exceeding anything seen in automotive applications. The ceramic used in conventional spark plugs, usually plain porcelain, simply couldn't handle it. It cracked under thermal stress, allowing hot gases to escape and ignition to fail. Champion needed a ceramic material that could withstand temperatures above 1,000 degrees, that could expand and contract repeatedly without cracking, and that would still maintain its electrical insulating properties. He experimented with different types of ceramics, testing alumina formulations, adding oxides to improve resistance to thermal shock, adjusting firing processes to create a more stable crystalline structure. Each test was expensive and time-consuming. Each failure taught him something new, but also consumed precious resources. And time was running out. On the European front, young American pilots were taking to the skies in machines that could fail at any moment, and Champion knew that every day of delay could cost lives. But the heat was only part of the problem. The electrode design was equally critical. The electrode needed to create a consistent spark through a very small airspace, usually less than a millimeter. But as the electrode heated up, it began to oxidize, accumulate carbon deposits, and eventually lose its ability to create a strong spark. Conventional electrodes, made of steel or common nickel, simply didn't last long enough in a high-temperature aircraft engine. Champion experimented with different alloys, adding chromium for corrosion resistance, tungsten for heat resistance, and adjusting the electrode shape to maximize heat dissipation surface while minimizing erosion. And then there was the problem of the seal. The spark plug needed to be threaded into the cylinder head in a way that created a perfect seal against high-pressure gases, but it also needed to be easily removable for maintenance. The gasket between the spark plug and the engine was a critical point of failure. If the seal failed, hot gases could escape, causing loss of compression and power. Worse still, if the seal was too tight, the spark plug could break during installation or removal, leaving pieces of ceramic inside the cylinder. An absolute disaster for any engine. Champion worked tirelessly, often sleeping in his workshop, testing prototype after prototype. He built his own testing facility where he could simulate the extreme conditions of an aircraft engine operating at full capacity. He subjected his spark plugs to brutal thermal cycles, heating them until they were red hot and then rapidly cooling them with cold water, repeating the process hundreds of times to identify design weaknesses. He tested them under extreme pressures, in fuel-rich environments, at temperatures beyond what any production engine could ever reach, because he knew that in aerial combat, pilots would push their engines beyond all safe limits. But there was another aspect of the problem that went beyond pure engineering. It was the question of large-scale manufacturing. Champion could make exceptional spark plugs in his workshop, one at a time, with meticulous quality control and attention to the smallest details. But the war demanded thousands, eventually millions of spark plugs. Each aircraft engine needed several spark plugs, and each spark plug had a limited lifespan even under the best circumstances. Creating a manufacturing process that could produce high-quality spark plugs on a large scale with perfect consistency was perhaps a greater challenge than the design itself. He needed to invent new molding techniques for ceramics, developing processes that ensured each piece had exactly the same shape, density, and properties. He needed to create new assembly methods where the electrode was fused into the ceramic in a way that created a perfect bond, without gaps where moisture or gases could seep in. He needed to develop quality control tests that could be applied to each spark plug produced, ensuring that no defective part ever reached an aircraft engine. And then, after months of exhaustive work, of failures and small victories, Champion finally had something that worked. It wasn't just a better spark plug, it was a revolution. His spark plugs could operate reliably in temperatures that would destroy conventional spark plugs. They maintained their strong spark even after hundreds of hours of operation. They withstood thermal shock, oil contamination, and carbon deposits. And most importantly, they could be mass-produced without sacrificing quality. But having a superior product was only the beginning. Champion now faced a different challenge, convincing a skeptical industry and a bureaucratic government that his spark plugs were the solution everyone had been looking for. The American aerospace industry was full of established suppliers, existing contracts, and resistance to change. And there was understandable skepticism. After all, many had promised solutions to the spark plug problem before, and all had failed. Champion didn't have time for the traditional sales approach. He went straight to the top, offering his sales for testing by the military themselves. He was so confident in his product that he was willing to put his reputation and his company on the line. He provided sales free of charge for field testing, insisting only that they be tested under the harshest possible conditions. He wanted the military to push them to their limits because he knew his sales could handle it. The results were spectacular. Engines that previously failed after a few hours of operation now ran reliably for dozens, eventually hundreds of hours. The rate of mechanical failures in aircraft engines dropped dramatically. Pilots who were used to flying with the constant fear of engine failure began to trust their machines. And aeronautical engineers, finally freed from the limitation that had plagued their designs, were able to begin developing even more powerful engines, knowing they had an ignition component that could keep up. The impact was immediate and profound. The American government, recognizing that it had finally found a solution to one of its most pressing problems, began placing massive orders. Champion's company, which started as a small operation, expanded rapidly to meet the demand. New factories were built, thousands of workers were hired, and Champion spark plugs began to equip not only military aircraft but also the increasingly sophisticated automotive engines. But Champion's true legacy went beyond production numbers or sales. He had fundamentally changed what was possible in aviation. Before his spark plugs, aircraft engines were limited in their power and reliability. Engineers had to make compromises, reducing operating temperatures to protect the spark plugs, which meant lower efficiency and less power. With Champion's spark plugs, these limitations disappeared. Engines could operate at their ideal temperatures, maximizing efficiency and power, and that meant airplanes could fly higher, faster, and farther. Champion's contribution to the American war effort cannot be underestimated. At a time when every technological advantage could tip the balance of power, he had given the Americans a critical edge. But beyond the immediate military impact, he had laid the foundation for the American aeronautical industry to become the most advanced in the world. Because once the fundamental problem of ignition was solved, engineers could focus on innovations in aerodynamics, structure, control systems, all the other areas that would eventually lead to the golden age of American aviation. Champion's story also illustrates something important about innovation. We often think of technological advances in terms of giant leaps, dramatic inventions that change everything at once. But the reality is that progress often depends on solutions to seemingly small problems, on improvements to components that most people never see or think about. The spark plug wasn't glamorous. It wasn't the part of the plane that appeared in photographs or that people admired. But without it working perfectly, nothing else mattered. The most elegant wings, the most powerful engine, the most skilled pilot, all of that was useless if the ignition failed. Champion understood this instinctively. He wasn't chasing glory or public recognition. He was solving a problem because it needed to be solved, because lives were at stake, because aviation progress was being hampered. And he was willing to do the hard, thankless work necessary to create a real solution, not just a temporary fix or a half measure, but something that would genuinely work under the worst imaginable conditions. As the war progressed, Champion's reputation grew. His sales became the industry standard, and his name became synonymous with quality and reliability. But even with success, he never stopped innovating. He continued refining his designs, experimenting with new materials, looking for ways to make his sales even better, even more reliable, even more durable. Because he knew that technology never stands still, that today's solution would be inadequate for tomorrow's challenges. After the war, as aviation began its transition from a military to a commercial technology, Champion's sales continued to play a crucial role. The first commercial aircraft, carrying mail and eventually passengers across continents and oceans, depended on the same fundamental reliability that Champion's sales provided. Pilots flying transcontinental routes, over mountains and deserts where any mechanical failure would be extremely dangerous, entrusted their lives to components that had to function perfectly every time. And they trusted Champion. The company he built eventually became one of the world's largest suppliers of automotive and aeronautical components. But for Champion, commercial success was secondary to the satisfaction of knowing he had solved a fundamental problem, that he had made a real contribution to the progress of human technology. He had come to America as an immigrant with little more than his skills and his determination, and he had built something that changed the world. But Champion's story also teaches us about the role of the individual in technological change. In an era of large corporations and massive research teams, it's easy to forget that many of the most important innovations began with one person. Someone who saw a problem that others ignored, someone who was willing to dedicate years of hard work to finding a solution. Champion didn't have unlimited resources or a huge team. What he did have was profound knowledge, unwavering determination, and a refusal to accept that the problem was unsolvable. And there was also the question of courage. Because Champion wasn't just trying to improve an existing product, he was essentially telling an entire industry that they were doing it wrong, that their methods and materials were inadequate. This required not only technical skill, but also the confidence to challenge the status quo, to insist that there was a better way even when others were skeptical. And it required the courage to put his own reputation and resources on the line, knowing that failure would mean not only financial loss, but also the discrediting of his ideas. The transformation that Champion brought about wasn't limited to aviation. His innovations in ceramic materials, manufacturing techniques, and quality control all had applications far beyond spark plugs. His understanding of how to create components that could withstand extreme temperatures and pressures influenced the development of many other technologies. The mass production methods with rigorous quality control that he pioneered became models for other industries. And his emphasis on testing products under extreme conditions, beyond nominal specifications, established a standard that is still followed today. But perhaps the most important aspect of his story is what it tells us about the nature of technological progress. We often look at the history of aviation and see the big names, the Wright brothers, Glenn Curtiss, Charles Lindbergh, people whose achievements were public and dramatic. But behind each of these milestones were hundreds of people like Champion, solving the less glamorous technical problems that made those feats possible. Aviation didn't advance because a few brilliant individuals had revolutionary ideas in isolation. It advanced because there was an ecosystem of innovators, each contributing their part, each solving a piece of the larger puzzle. Champion lived to see aviation transform the world. He witnessed the first transcontinental commercial flights, saw aviation revolutionize long-distance transportation, saw airplanes evolve from fragile wooden and canvas machines into the sophisticated metal aircraft that would dominate the skies. And in each of those airplanes, in each engine that powered them, there were components whose design was influenced by the work he began. His contribution was invisible to most people, but fundamental to everything that came after. Champion's life also illustrates the American story of immigration and opportunity. He came from another country, speaking English as a second language, without wealth or family connections. But America offered him something he might not have found elsewhere: the opportunity to build something new, to compete based on merit and results rather than origin or social class. His story is part of the larger narrative of how America became a leader in technological innovation, not because it had a larger population or more natural resources than other countries, but because it was willing to welcome talent from anywhere and give people the freedom to experiment, to fail, and to try again. And there was also a human dimension to his story that cannot be ignored. Each perfectly functioning spark plug represented a pilot who returned home safely, a mission completed, a life protected. Champion wasn't working with abstractions or numbers on a spreadsheet. He was working on a problem where failure had serious and real consequences for real people. And that awareness, that weight of responsibility, certainly influenced his obsessive dedication to quality and reliability. He couldn't afford to be careless or accept compromises that reduced safety, because he knew the consequences would directly affect human lives. In the following decades, as aviation continued to evolve, the challenges changed. Engines became more powerful, operating temperatures increased even further, and new problems arose. But the fundamental approach that Champion established, to deeply understand the problem, to test exhaustively under extreme conditions, to never accept anything less than absolute excellence. This approach continued to guide the development of aeronautical components. His legacy was not only the specific products he created, but the culture of engineering excellence that he helped establish. Today, more than a century later, when we board a commercial airplane and fly across continents, we rarely think about the thousands of individual components that make that flight possible. We don't think about the spark plugs, now technologically advanced but still fundamentally based on the same principles Champion established. We don't think about the work of countless engineers who solved obscure technical problems to ensure that every system functions perfectly. We assume the plane will work, that the engine won't fail, that we will arrive at our destination safely. And that confidence, that ability to treat flying as something routine and safe, was built on the foundations that people like Champion laid. The story of Albert Champion also reminds us that the solution to big problems often comes from unexpected directions. He wasn't an aeronautical engineer by training. He didn't have a pedigree from prestigious universities or direct experience in aircraft design. He was a motorcycle and automobile mechanic who understood that the fundamental principles of combustion and ignition were the same, regardless of the application. And it was precisely this external perspective, this ability to look at the problem with fresh eyes, without being bound by the assumptions and limitations of the existing industry, that allowed him to see solutions that others had missed. This raises an important question about how we approach complex technical problems. Often, deep specialization can become an obstacle, where experts are so immersed in existing solutions that they fail to imagine radically different alternatives. Someone from the outside, with knowledge in related areas but not exactly the same specialty, can bring fresh perspectives and make connections that established experts never considered. Champion's story suggests that we need to value not only deep expertise but also the ability to apply knowledge from one domain to problems in another. And there was also a critical timing dimension to his story. Champion developed his high-temperature sails precisely when they were most needed. If he had come a decade earlier, aviation still wouldn't have been ready to use his technology. If he had come a decade later, others might have solved the problem first. There's an element of synchronicity, of being in the right place at the right time with the right skills, that can't be ignored. But that synchronicity only works if you're prepared, if you've spent years developing the skills and knowledge necessary to recognize the opportunity when it arises. The company Champion built continued to innovate long after his lifetime. It expanded into other automotive components, developed new technologies, and adapted to changing markets. But it always maintained that fundamental focus on quality and reliability that its founder established. And that is perhaps one of the most enduring legacies any entrepreneur can leave. Not just successful products, but an organizational culture that embodies his values and continues to drive excellence long after he is gone. But returning to the specific impact on aviation, it's difficult to overstate how fundamental solving the high-temperature ignition problem was. Without this solution, the development of high-power aircraft engines would have been impossible or at least severely delayed. And without these engines, all subsequent evolution of aviation would have been different. The World War II bombers that could carry heavy loads over long distances, the fighter planes that reached ever-increasing speeds, the first jet aircraft that would eventually replace piston engines. All these developments depended on having fundamental reliability in the ignition system. And there were massive economic implications. Commercial aviation, which had become one of the world's largest industries, depended absolutely on reliability. Airlines couldn't operate if their planes were constantly breaking down. Passengers wouldn't fly if they didn't trust that they would arrive at their destination safely. The entire industry was built on the premise that airplanes were safe and reliable, and that reliability started with fundamental components like spark plugs working perfectly every time. The story also illustrates the interconnectedness between civilian and military innovation. Champion developed his sails primarily to meet military needs during the war, but the knowledge and technology he created quickly spread to civilian applications. Automotive engines benefited from the same innovations, becoming more efficient and reliable. And as more cars and airplanes used high-quality components, the cost of manufacturing fell through economies of scale, making the technology accessible to a wider market. This virtuous cycle, where innovation in one area drives improvements in others, is characteristic of how technological progress truly happens. Champion faced many challenges beyond the purely technical. He had to navigate the complexities of government contracts, competition with established companies, and intellectual property protection in an era where patent laws were less clear. He had to build not just products, but an entire organization capable of manufacturing them at scale. He had to train workers, establish supply chains, and secure funding for expansion. Technical success was only the beginning. Transforming a brilliant invention into a viable business required a completely different set of skills. And he did all this while maintaining his focus on quality. It would have been easy, especially under the pressure of wartime demand, to cut costs or accelerate production in ways that compromised quality. But Champion understood that his reputation depended on every sale his company produced functioning perfectly. A single failure in the field, especially one that put lives at risk, could destroy everything he had built. So he maintained rigorous standards, even when it meant slower production or higher costs. And that integrity, that refusal to compromise quality for short-term profit, ultimately became his greatest competitive advantage. As we approach the end of the story, it's worth reflecting on what it teaches us about innovation and entrepreneurship. Champion didn't wait for permission or official approval to begin his work. He saw a problem, believed he could solve it, and started working. He used his own resources, took personal risks, and worked tirelessly without any guarantee of success. And when he finally succeeded, the impact extended far beyond his own financial gains. He contributed to the safety and progress of an entire industry, saved countless lives, and helped establish America as a leader in aviation. This story also reminds us that technological progress doesn't happen in isolation. Champion benefited from being in a country with an advanced manufacturing industry, access to quality materials, a legal system that protected innovation, and a market large enough to justify investments in new technologies. He benefited from clients, both military and civilian, who were willing to try new products if they offered genuine advantages. And he benefited from a culture that valued innovation and was willing to reward those who brought real solutions to real problems. But above all, Albert Champion's story is about the importance of not accepting limitations as permanent. When everyone said that the problem of high-temperature spark plugs was unsolvable, or at least couldn't be solved with the available technology, he refused to accept that. He believed there had to be a way, and he was willing to invest the time and effort necessary to find it. This mentality, this refusal to accept the impossible, is what drives all genuine progress. And it's what separates those who only talk about change from those who actually bring it about. When we look to the sky today and see planes crossing continents in a matter of hours, when we board a flight and don't even think twice about engine safety, when we treat aviation as something routine and commonplace, we are living in a world that people like Albert Champion helped to create. His contribution may not be as visible as that of a famous aircraft designer or a record-breaking pilot, but it was equally fundamental. Because without solving that seemingly small problem of reliable ignition, nothing else would have been possible. And perhaps that is the most profound lesson of its history. That great achievements are built upon the foundations of countless small accomplishments. That each problem solved, each incremental improvement, Each innovation in seemingly mundane components all accumulate to create the technological marvels that transform our civilization. That we should honor not only the visible pioneers, but also the countless engineers, inventors, and entrepreneurs whose hard work and dedication make progress possible. Albert Champion rewrote the rules of aviation not through grand pronouncements or dramatic designs, but through meticulous work, exhaustive testing, and an unwavering commitment to excellence. He proved that when faced with fundamental technical challenges, the solution lies not in circumventing the problem or accepting compromises, but in diving deep, understanding every aspect of the difficulty, and working systematically and persistently until a real answer is found. And he demonstrated that a person with knowledge, determination, and integrity can make a genuine and lasting difference in the world. May God bless all those who, like Champion, dedicate their lives to solving problems that make our world safer, more efficient, and more connected.